Hi learners, welcome to the today's topic. Today's topic is issue regarding classification and prediction and BAP propagation. Myself Priyanka Gupta, I am working as Assistant Professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. Let's start. I'll cover the topics. We will see what are the different issues between classification and prediction. We will cover the classification by BAP propagation, what is BAP propagation and what is neural network. What is the working of BAP propagation, what is the algorithm and different basics of the BAP propagation. So what are the different issues regarding the classification and prediction while we are going to opt for the classification for any data set? So the major issue will be the preparation of data. The preparation of data while we are going to prepare the data. So some of the issues can come there. What issues? The preparing the data in pre-processing phase, that is called as a pre-processing phase. Before the process, we are going to prepare the data while we are going to process the data. So that involves first we are doing the data cleaning. First we have to clean the particular data. So while we are going to do the particular data cleaning, so that involves the removing the noise and as well as the outliers, and then we have to treat about the what are the missing values are there. So that will call as a data cleaning, right? So the noise will be removed. How to remove the noise? Basically, the noise will be removed by the applying some of the smoothing techniques. Some of the smoothing techniques will be there, and the problem of missing values is solved by replacing the missing value. We have to replace the missing value by the another value, that is the average of the value, which is the most commonly occurring in the further that attribute. So we will replace that value by that particular value. So like that we have to recreate the we have to reassign the other missing values. So this defines the pre-processing of data to eliminate, we can say to remove, or we can say reduce the noise or outliers by using smoothing techniques, the smoothing methods and the operation of missing values. So we have talked about the what are the names of the different smoothing techniques. So we have used in earlier lesson what Laplace transformation, Laplace reduction. So that was the smoothing technique. So we can use there are many techniques. So that is the operation of missing values, that is restoring a missing value with the most commonly appearing value. For that we have to check the value, whatever the value is the average of all the value, and what is the most commonly occurring value, what is the mode of that particular data set. So we can replace the mode with the particular missing value. So that will be the smoothing operation for that particular missing value. So there are different classification algorithm are there, that is having some structure, for managing this type of noise, this type of missing value, we can say the outliers. So this step can support reducing the confusion. So the user, whatever the end user is there who is going to use that data, they cannot confuse with the data whatever it is there in the database data set. So while either the model is going to, either the machine is going to learn about that in the learning phase. So we have to pre-process that data before we are going to process the particular model. So that will be the that will be the smoothing technique. So before the pre-process, we have to do this type of smoothing techniques. We have to apply these type of smoothing techniques, and we have to remove the missing values from there. Second issue can be there before the process, in pre-processing phase, the relevance analysis. So the database may also can have the relevant values. Some data can have the irrelevant value. So they cannot, if suppose there is a quantitative data, so if there is some numerical data there, so that will be the irrelevant attribute for that particular data set, particular records. So that this type of relevance we can have to remove from there. So the correlation analysis will be applied there. So the correlation analysis is nothing but it is going to use for to know how whether the two of the given attribute are they are related or not. So they are, if they are related, so we have to apply some of the other techniques. So there are various attributes in the data that can be irrelevant to the classification or we can say prediction task. For example, if there is a data that recording the day of the week, the day, what are the days in the week on the on which the bank loan software was filled, is impossible to be irrelevant. That is impossible, improbable to be relevant to the success of the software. So that cannot be do any impact if days of the week will be differ to each other. So moreover, some of the different attributes can also be redundant. So therefore, the relevance analysis can be implemented on the data. What are the data we have to delete? Some of the irrelevant data, redundant attribute who are occurring again and again. So like these type of data we have to remove from the learning process. Before the model is going to learn from that, we have to remove the data in pre-processing phase. And in machine learning, we can say this step is referred to as a feature selection. So we have to select the some of the particular features for the better analysis for the model. So we have to remove, we have to extract the data what we need to process in the before the pre-process and after the pre-processing phase. So it we can say it contains the such of the attributes, some of the values that can otherwise can be slowed down and likely mislead the learning process. So to rid of this type of misleading and we can say wrong learning phase, we have to remove these type of redundant as well as irrelevant and missing values from the data. So correctly the time on relevance analysis, when that inserted on time used on learning phase from the resulting reduced feature subset. So there will be the feature subsetting while we are going to select some of the particular feature. So that we have to check it must be less than the that would have been used on learning from the initial set of features. So that we can understand, we have to remove those of the particular features, a feature subset before the processing of that particular data set. So in the pre-processing phase, before the time we have to read of that data, that type of data set or values, while it is going to mislead the learning phase. So therefore, such type of relevance analysis, they are going to help to boost the classification effectiveness. So that if there will not be that type of data, the data will be smooth and that will be very, very simple and for scalable processing. So the data can will be that so the process of classification will be very, very smooth. Third issue can be there while we are doing the classification and prediction, that can be the data transformation. So what is data transformation? While we are going to change the data type from one type to another type, so that will be the transformation. In simple terms, the data can be transformed by some of the methods are there. On the basis of that, we can transform the particular data. So the first is normalization. We have to normalize the data. The data will be transformed using normalization. The normalization phase, a method that involves the scaling of all values. that will scale the all values are there in the data set for a given attribute to make them fall within the some small specified range. So what is normalization between basically if some values are there, suppose some we can say some values are there 1 to 1 lakh. So there are some data that it comes under the 1 to more than 1 lakh. So what we have to do that what the model will has to do, the model has to normalize the data between the some specific range. So there will be the all the data set what is falling between the 1 to 1 lakh, more than 1 lakh. So we will set a particular range from 1 to particular 1 lakh or more than 1 lakh. So that will be the range, small range. But we have to set the small range where all the data will be there in that particular data set. So like that we have to set the model have to set the some criteria on the basis of that small we can say specified range. The all the data will false. All the data will be normalized by the computer, by the system. So that will be the normalization phase of the data transformation. Normalization basically is used when the neural network, or we can say those are the method that is going to involve the measurement that are used in the learning step. So those of the all type of steps or what are the methods are there that will be involved in the normalization. The normalization is going to include the scaling of all attributes, all values for a given attribute, so that they cannot decline, they cannot remove inside a small specific area. So there will be the some what I have said some specific range we have to set. The specific range will be like suppose the normalization can be between the -1 to +1. So like these type of small scaling we have to apply on the same of the data set. We can say to 1 to 1.0. So these type of small scaling should be applied in the transformation phase of the normalization. So in these of the approaches, these are the methods that can apply distance measurements. For example, this can avoid the attribute with the originally high range. So what are the what are the ranges are there that is high in value? That I have told you that can be more than 1 lakh. Like for example, so that kind of that type of values we have to normalize into the particular value. Such as if we will take the example of income, so that can vary from that will basically depends on the demographical area. So that type of measurement we have to set into the particular small specified ranges. So the third is the generalization. So what is generalization? The data that can also be transformed by generalization that is having the higher concept. So for the generalization of any of the data set, we can use the concept hierarchy. So what is concept hierarchy? The concept hierarchy is nothing but that is having the some of the hierarchy, some of the hidden hierarchy that is having the long association with the other attributes. So this is the data can be generalized to a larger level approach. So there will be the some tree-like structure that so that we can call that is a hierarchy, and that type of concept hierarchy can be used for this goals for generalization. So this is especially used for, this is basically going to help for continuous value attribute. So what are the attributes are there who are continuous in nature? Like if interval scale values are there, suppose 0 to 10, 10 to 20, 20 to 30, like that specified values are there. So that type of values can be generalized by using this type of normalization techniques. So for instance, the mathematical value for the attribute that income can be generalized to the discrete field, like if we can say that can be low, that can be medium, that can be high. So if we will add a one class level, that is going to call as it is the type of the income. So that will come as a in high, low, and particular medium. So like these type of classification and generalization we can use in this transformation phase. So like this, nominal valued attributes can also be there, such as street, that can be generalized to larger level approaches such as city. So what I have said, that will be the that there would have some of the association, there would have some of the relationship. So that can be a we can say behind the scene relationship. So because if we will write address, so there will be the pin code. So that particular pin code can occur into the particular district, particular post office. So like that can be broader in the while we are going to think about that. So it can be come into the city, it can come into the district, it can come into the we can say state. So like that will be the that would be the concept hierarchy for that particular pin code. So so for the nominal valued attribute, we can also apply the generalization. Because of these generalization technique of normalization, there would have the sort that is going to shorten the initial training data. So while we are applying the training data for to learning of the particular model, so fewer of the input output operation can be included during the learning step. So that will be the learning step for the that particular model. So we can apply the input output operations also. So the data can be normalized, especially when neural networks are techniques containing the distance measurements that is used in the learning phase of the model. So these type of processes and techniques we can apply in the generalization. Now, so that topic has completed. That was the issues regarding the classification and prediction. So now we will go into the how we are going to do the classification that is used by the backpropagation. So backpropagation term is that comes under the neural network. So here we will see what is what is backpropagation. Then we will see how it comes under the neural network. So what is basically backpropagation? Backpropagation is nothing but that is a neural network learning algorithm. That is a learning algorithm for the model that backpropagate the error. That is going to backpropagate the error and from the output nodes to the input nodes. So now we will take this example in the figure. Here we will first we will understand about this is the basically a neural network. So this is the structure, like we are having the neurons in our brain. So we will have an initial idea. So there should have some of the spikes, some of the neurons. So that is connected over the brain tissues, and that is communicating the one of the instruction. If we have to think, if we are going to think, so that particular instruction that is going to come across the neuron, and that is going to process in the brain. So like these type of processing, that particular processing will be followed in the neural network. So this is basically the neural network. Here we can see here that is the these are the inputs. So that is x1 to xn. These are the input that works as basically neurons. So there are 1, 2, 3, 4 and many neurons are there that will be associated with the activation function. So there will be the activation function, and before that the summation of all the neurons will be there at a one point. So that will be the summarization junction. So here all the inputs as neurons will be associated here, but before that the weightage for each of the neurons will be there. Weights will be there. That is the input, and that is the weight. And on the activation we can say summarization function, there would have some bias. So bias that will be applied on each of the neurons. So here the all how to calculate these of the summation. So that x1 into w1 will be there, and plus x2 plus x2 into w2, like that. All the particular weightage will be first it will be multiplied, then it will be calculated like summation. So like this, and the bias also will be applied in this phase, and then after that will be the input for that activation function, and then we will get the output. So same like that our brain is working in the our mind. So that is basically came by that particular brain concept. So now we will see the neural network field was originally kindled by the psychologist. Basically psychologist, they are using that particular concept. The neurobiologist, they are using that particular subject, who sought to develop and they are going to test the computational analogs of neurons. So I have told you what are neurons in the brain. So that particular all the concepts that will be taken by the psychologist, and here we will taking as a neural network. So the neural network is a set of connected input and output units in which each of the connection has a weight associated with it. So as I have said, there would have the input and there would have the weight. That is the weight. So that would be associated with each of the particular neuron. Now, during that learning phase, so here also we have to learn the model. So before that, during that, the network learns by the adjusting the weights. So here the weights are there that would have some of the we can say some adjustment. So that adjustment will have, then only we are going to the model is going to learn about the something else. So as it will be able to predict about the correct class levels for the particular input class levels, so input tuples. So it is going to use as a vast application of neural network in data mining, like character recognition. So because that is going to be deeply connected, deeply trained to the different input data tuples, so that is very very effective and beneficial. So we are widely going to use this neural network concept and backpropagation concept in classification. So if the application there like character recognition, signature verification are there, or OCR are there, so we would likely were going to use the backpropagation as well as neural network. So now we will see what are the basics of neural network. So neural network are an information processing paradigm, a technique inspired by the human nervous system. So as I have told you the example of brain, so that basically works as a nervous system. So that is nothing but the nervous system. So each neurons receive a signal through a synapses. So synapses will be there. So one signal will be there that is going to the neurons, and which controls the effect of the signals on the neuron. Just like in the human nervous system, we have biological neurons in the same way in neural network that is having in the artificial neurons. So artificial neurons are mathematical functions we are having in this neural network that is basically derived from that biological neurons. That is stating that. So the human brain is there that is estimated to have the 10 billion neurons. More than 10 billion neurons, and that is each of the connected to the an average 10,000 neurons, other neurons. So if some neurons are there like this, there would have some structure that is also connecting like this. So there would have the thousands neurons will be there in the brain. So that is a structure like neuron. So basically the backpropagation that computes the gradient, that is going to compute the gradient of the loss function and with respect to the network weight. So we have seen the network weights were there. So irrespective of that, the gradient will be there that is going to compute that is going to calculate the loss function. So what is the loss for that particular neurons, that will be calculated while it is back propagating the same output as an input. So it is very efficient, and rather than the naively directly computing the gradient with respect to the individual neurons, individual weights. So back propagation works like that. This effectively makes it possible to use the gradient models. The gradient methods will be there to train the multi-layers networks as well as the neurons, and that is going to update the weightage. Again, in the first cycle, it is going to update. That is going to calculate the weight for first of the step. That again, if that will be back propagate. What is back propagation? That is again coming back to the output as an input. So like that, the we can say that will be the repetitive in nature. So like these type of weightage will be recalculated again and again. So it will be update the weightage to minimize the loss. What is the minimum loss is there, that is going to calculate that. So that is a very specific we can say rule for that. So that variance such as gradient descent, that is calling as a that loss less loss of the that function, that is called as a gradient descent or stochastic gradient descent. For that we are going to calculate the loss function. So the back propagation algorithm basically works by computing the gradient of the loss function. So with respect to each of the weights. So what I have said, the weight will be updated again and again for each of the iteration. That is a chain rule. So why we are calling this chain rule? Because that is a repetitive in nature, iterative in nature. Again and again, the weightage have to be updated. So computing the gradient layer by layer and iterating backward from the last layer to avoid these calculations, the computations of intermediate terms will be work as a chain rule. So the loss function, the loss function again will be recalculated, and that will be minimized. So the gradient descent is nothing but that is a minimization of the particular loss function. Now, the working with back propagation. So neural network used as a supervised learning to generate the output vectors from input vectors. That is the network operates on. So that is this supervised learning, because we are training the that particular model initially. So that is the supervised learning, because we know about the class labels. So then it is going to adjust the weightage according to the error, and we are going to get the desired output. What we want as a desired output, till then we have to apply that particular we can say weightage. We have to adjust that weightage. Now the back propagation algorithm comes. So algorithm is neural network learning for classification. We can say numeric prediction using the back propagation algorithm. So input will be a dataset consisting of the training tuples and their associated target values. Now the I will be the learning rate. The network will be the multi-layer feed forward network. So what is feed forward? That is going to be feeding all the weightage and we can say the inputs, and then it is going to forward it to the other channel. So that is the feed forward network. Output will be what we want as a desired output, a trained neural network. So the method will be we have to initialize all weights and bias in network. First step. Second step, while terminating condition is not satisfied, so we will apply a for loop. Each training tuple acts in D. Now propagate the input forward for each of the input that is having the layer unit J. So the OJ will be the output J is equal to input J. So output of an input unit is the actual input value. So for each of the hidden output layer J, again we will call the for loop. Now Ij will be calculated. Ij is equal to summation of I Wij Oi plus theta J. So that is computing the net input. That is the net input of the unit j with respect to the previous layer. So that is the previous layer with respect to the previous layer. Now, so here Oj is equal to 1 upon 1 plus E minus Ij. So that is computing the output of each unit j. Now we will in this algorithm back propagating the error. So now the error will be calculated. Now again the for loop will be there, each unit j in output layer. So now error will be calculated. Error of j is equal to Oj 1 minus Oj and Tj minus Oj. That is computing the error of that network. Now for each of the unit j in hidden layer, for hidden layers now we will calculate from the last to first hidden layer. So while the network will be there, the first initial first layer will be there, the last layer will be there. In between the layer we cannot see, we cannot imagine. So there will be the many hidden layers. For that we have to calculate that particular error. So error j is equal to same Oj 1 minus Oj and summation of k error k wjk. That is computing the error with respect to the next higher layer, that is k. So for again the for loop will be there for each weight wij in network. Now the wij will be calculated, that is the gradient descent, the L error j into Oj. So that is the weight increment. Now wij is equal to that was the summation of weight. Now wij is equal to wij plus theta wij. So that the theta wj it was the increment for that. That was the increment in that particular error. So now that will be calculated with the particular earlier weightage were there. So that was the earlier weight. Now it will be added to that layer. So that will be the weight update. Again for loop will be there, that each bias theta j in network delta theta j is equal to L into error j. That is the bias increment we are doing here. So now we will update that theta j is equal to theta j plus summation theta j. So now that bias will be updated. So the algorithm will work like that. So now we are going to initialize the weight. The statements are there, particularly what we are going to do. So the weights in the network are initialized to small numbers, that is ranging the -1 to 1 and -5 to +5. That is the example I have said in the earlier slide. Each unit has the bias associated with this that we have to explain later. So the biases are similarly initialized to small random numbers. Each training tuple X is processed by the following steps. First, we have to propagate the input forward. First, the training tuple is going to be fed to the network layer, network input layer. The input passed through the input units, that will be not changed. Then it is for an input unit j, its output will be Oj is equal to the input Ij. So that was stated in the algorithm as well. So next, the net input and output of each unit in the hidden and output layer will be computed. So here in this example, we can see the inputs are there, the weighted sum are there, and the activation function. So that is the another figure of that particular example. So that is nothing but there will be the hidden and output layers. So the net input of that unit in the hidden output layer will be computed as a linear combination, that will be the calculated into the chain rule. So to help to know about this is illustrated in this particular figure. So that is nothing but that are coming into their hidden layers. So each such unit has a number of inputs to it, and there are in fact the outputs of the units that connected to the previous layer. So that will be connected to the previous layer. So because that is back propagation, that is output is coming to the input. So each connection has a weight. To compute the net input, each input connected to the unit is multiplied by its corresponding weightage. So that will be that will be calculated, that will be plus, that will be summed, that will be actually multiply, and that will be summed after that. So given a unit j, the hidden and output layer, the net input Ij will be there. Ij is equal to summation of I wij into Oi plus theta j. So where wij is the weight of the connections, that is I to j, and Oi is the output of layer, and theta j is the bias of the input. So the bias acts as a threshold, that is basically a threshold for that is serving the variance between the activity of the unit. So the function symbolizes the activation of the neurons that is presented by the unit. So the logistics or sigmoid function can be used for that. So we will talk about in brief what is sigmoid and logistic functions are there. So the output will be there, Oj is equal to 1 upon 1 plus E minus Ij. So this function also referred to as a squashing function that is coming into the range, smaller range, 0 to 1. So we have to compute the output value Oj for each of the hidden layer up to and including the output layer, which gives the network prediction. So like this, the prediction is going to be given. So that was all about the basics of the back propagation and neural network. So we have seen what are the issues between the classification and prediction, and we have also covered what is basically how the back propagation is working and what is the base of that is particular the neural network. So we have seen what are the particular basics of the neural network, how it is going to used in the back propagation. So that was all about today's topic. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.